In this video, I'd like to introduce inequalities. I'd like to discuss how to solve inequalities, graph inequalities, as well as how to represent the answer using other inequalities or using what's called interval notation. Alright, so what do I mean by an inequality? So an inequality says what is bigger or smaller or equal to something else. So 3 is less than 10, 4 is bigger than 1, 5 is less than or equal to 6, but 5 is also less than or equal to 5. Okay, so it's less than or equal, that's what that symbol means. I can also say 5 is greater than or equal to 5. Okay, I cannot say 5 is greater than 5, however. So those are the four inequality symbols that we'll be dealing with, and you can have expressions, you can have inequalities that have variables, and then you could ask what are the variable values that satisfy a certain inequality. Alright, so for example, suppose I said that some mystery number plus 1, that's going to be always bigger than 3. So what values can I add 1 to them, and they'll always be the set of values that if I add 1 I'll get something bigger than 3. Alright, well, so let's see, 10 certainly numbers bigger than 3, 4, 5, 6, 7, 8, 9, 10, 11, etc., but also decimals. Okay, 3.1, 6.8, pi. All right, so there's an infinite number actually that can satisfy this inequality, and rather than playing hit and miss trying to guess all the values and struggling with listing it, let me show you a better way to solve an inequality. And in a lot of ways it's similar to how you solve an equation. All right, so if instead of a greater than symbol, if I had and that's what this is called, by the way, that's called a greater than symbol. Maybe I should give you the names I'll be using. So the 4 is greater than 1, so we call this one a greater than symbol. 3 is less than 10, we call that a less than symbol. And 5 is less than or equal to 6, we call that the less than or equal to symbol. 5 is greater than or equal to 5, we call that the greater than or equal to symbol. Alright, so getting back to this problem. So x plus 1 is greater than 3, and I said I was starting to say that we're going to solve it as if the greater than symbol was actually an equal symbol, so that we had an equation. If this was an equation, we would maybe subtract 1 from both sides, and look at that. You get a nice simple equation that says everything bigger than 2. Okay, and so that is the cleanest way to express all the values of x that satisfy the original inequality. Alright, all values of x, all values greater than 2. So you can plug in 2.1, you'll see that that satisfies the original inequality. Alright, now let's do a couple more. What about if I had 2x minus 7 is less than or equal to x minus 4? Alright, again, treating it like as if it was an equation. If this was an equation, we might subtract x from both sides. We might add 7 to both sides. And so that would give us x is less than or equal to 3. Alright, and that's a nice clean way, probably the cleanest way I can think of, to express all the x values that satisfy the blue inequality. Alright, x is less than or equal to 3. Go ahead and plug in, and by the way, I do encourage you to plug in at least one value, especially if you care about getting it right on the first try. For example, on the exam. Alright, plug in, let's go ahead and do that just so I can show you what I mean. So if this is really true, then if I plug in 0, because 0 is less than or equal to 3, right? That should satisfy the blue inequality. So 0 minus 7 is less than or equal to 0 minus 4. Is minus 7 less than or equal to minus 4? Yes. Okay, so it checks out. All right. Now, the first one, let's go back to the original inequality. X plus 1 is greater than 3. So the solutions are everything bigger than 2. So if I plug in 0, it should not satisfy the inequality. Let's try that. So the first one would give 0 plus 1 is bigger than 3, or 1 is bigger than 3, and we know that's wrong. All right. Now the reason I did both examples with 0 is that's a very easy value often to plug into an equation, right? So even if you just plug in 0, you're going to get a lot of mileage out of just that little bit of work. Okay? Now, all right, and there's going to be more to say later about solving inequalities, but that is enough to get us started. We're asking for the values such that the original inequality is satisfied. All right, let's talk about graphing. So how would I express all numbers greater than 2? How would I make a picture version of that answer? All right, so imagine that you had a number line. Okay, so everything bigger than 2, the way that you picture that is, well, you start at 2 and you emphasize everything to one side. So for example, we would make an arrow, maybe with a highlighter or something, and so that means we're highlighting everything to the right. So everything in yellow satisfies the inequality. All right, something like that. You can use a darker highlighter if you like. Okay, now notice that I put an open circle. An open circle implies that we don't include that point. So 2 does not get to join the club. It's not one of the answers. All right, let's do the second inequality. All right, so let me make another number line. And this time you'll notice that the answer, the symbol is less than or equal. So this time we're going to have to include the point where it starts. All right. Now because we have to include the point where it starts, we're not going to use an open circle like we did for the first one. Okay. So what we do for this one is we use a darkened circle. Okay, a darkened circle means yes, we also include the point. Okay, and then we highlight everything to the correct side. In this case, it's the left. So you take your marker and you highlight everything to the left of that point. Okay, and then the arrowhead signifies that we're not done. It keeps going to, and in this case, it goes all the way to negative infinity. Okay, grows to the left without bound, or however you want to say it. Okay, and so that's how you graph an inequality, as they say. Okay, now let me show you another way you can express the same two solutions. Okay, you can also say, instead of you saying a variable is bigger or less than something, you can give a range with parentheses. This is, or brackets. This is called interval notation. So what I just graphed, I'm going to put a different way of saying the same answer above the graph. Okay, everything bigger than 2, everything basically between 2 and infinity, right? That's one way of saying that. We're gonna express, the purple expression is saying the answers are everything in between these two numbers. All right, let's do the bottom one. Okay, once again, we're going to say everything in between two numbers. In this case, minus infinity and 3. Okay, now infinity is not really a number, so we have to add some qualifications. Okay, when we say infinity, what we really mean is we really mean that every number bigger than 2. Okay, at the bottom when we say negative infinity, what we really mean is every number that's less than 3. All right. Again, I'm not claiming there's such a number as infinity, and it certainly doesn't follow the normal math rules. All right. Let me bring one last thing to your attention. Notice that for the first purple answer, notice that I have a left parenthesis and a right parenthesis, and notice on the bottom one I have a left parenthesis and a right bracket. All right. Now the bracket is how the difference between a bracket and parentheses, how we do the equivalent of the open circle and the closed circle. Okay, so the bracket, this one includes the endpoint. This one includes 3. All right, on the top, because you have a parenthesis, does not include 2. All right, so keep that in mind.